You wouldn't hear it coming. There would be no warning, no countdown, no siren. One moment, you'd be standing in your kitchen, coffee in hand, sunlight cutting through the blinds exactly like it does every morning. The next moment, everything not bolted to the ground would be moving at over 1,000 miles per hour, including you. Because right now, as you sit there watching this, you are spinning. The ground beneath your feet is racing through space faster than a rifle bullet. You don't feel it because everything around you, the air, the buildings, the oceans, is spinning at the exact same speed you are. But what happens the instant that stops? Let's find out, because the answer is far more violent and far stranger than you think. If Earth's rotation stopped gradually over days or weeks, we'd barely notice. Life would adjust. Sunsets would get long, then longer, until day and night each lasted 6 months. But that's not the scenario we're exploring. We're talking about Earth stopping suddenly, in a matter of seconds. And physics has a name for what happens to anything moving fast that suddenly isn't. Momentum doesn't just vanish, it has to go somewhere. At the equator, the Earth's surface moves at roughly 1,037 miles per hour. That's faster than most commercial jets. Everything on that surface, you, your house, the ocean, the atmosphere, is moving at that same speed. If the ground stops but you don't, you keep moving. At 1,000 miles an hour, that's not a stumble. That's being launched off the face of the planet like a bullet leaving a barrel. Every person standing outside, not anchored to something solid, would be flung eastward at hypersonic speed. Cars, trees, entire buildings not deeply rooted in bedrock would be torn from their foundations and hurled through the air. This wouldn't be an earthquake. This would be the entire surface of the planet trying to keep moving while the rock underneath it didn't. Now picture the atmosphere. Air isn't bolted down, it's a fluid, and fluids resist sudden changes in motion even more dramatically than solid ground does. If the crust of the Earth stopped instantly but the atmosphere kept moving at rotational speed, we'd experience winds of over 1,000 miles per hour scraping across the surface. For comparison, the strongest hurricane winds ever recorded top out around 215 miles per hour. This would be nearly 5 times more powerful than the most catastrophic hurricane in history, but everywhere, all at once, all over the planet. These winds wouldn't just knock down buildings, they would sandblast forests down to bare rock. They would rip topsoil from farmland and scatter it across oceans. Mountains would erode visibly in hours, instead of over millions of years. Every structure humans have ever built, skyscrapers, dams, cathedrals, would be reduced to rubble and scattered debris within minutes. Water behaves the same way as air. The oceans, still carrying the momentum of rotation, would surge violently toward the poles. Since Earth's spin is what currently keeps water bulging slightly at the equator, we're talking about mega-tsunamis, walls of water taller than any building on Earth, sweeping across continents. Coastal cities wouldn't just flood, they would be erased. And this wouldn't happen once. The water would keep sloshing back and forth across the globe for days, maybe weeks, as it slowly found a new equilibrium on a planet that no longer spins. Let's say somehow life survived that first catastrophic hour. The story isn't over, it's just beginning. Earth's rotation is the engine behind its magnetic field. Deep in the planet's core, molten iron churns and swirls because the planet spins, and that churning generates the magnetic shield that wraps around Earth, deflecting deadly solar radiation. Stop the spin and over time that shield weakens. Without it, the solar wind, a constant stream of charged particles from the sun, would begin stripping away our atmosphere, the same way it stripped Mars of its atmosphere billions of years ago. Mars was once a planet with rivers, lakes, maybe even oceans. Scientists believe its slowing core and fading magnetic field are a major reason it became the dead, radiation-blasted desert we see today. A non-rotating Earth would be walking that same path. If against every odds some form of life clung on, the planet itself would look unrecognizable. Without rotation, there would be no more day-night cycle from spinning. Instead, one side of Earth would face the sun constantly, while the other stayed locked in permanent darkness. The sunlit side would bake under endless daytime heat. Temperatures could climb well past what any known life form can survive. The dark side would freeze into a permanent ice age, plunging to temperatures cold enough to freeze carbon dioxide out of the air. Only a narrow twilight band between these two extremes. A ring around the planet might offer temperatures mild enough to support any kind of life at all. Everything else would become uninhabitable wasteland. One side an oven, the other a frozen tomb. Here's the strange twist. Life is resilient in ways that are almost hard to believe. Deep-sea organisms living near thermal vents don't depend on sunlight or day-night cycles at all. Certain bacteria survive in conditions of extreme heat, cold, and radiation that would kill nearly everything else. If any life survived the initial chaos, It's these extremophiles that would have the best shot at enduring what comes next. But for humanity, for agriculture, cities, complex ecosystems, a non-rotating Earth would almost certainly mean extinction, not overnight, but within a devastatingly short window of time. The truth is, Earth's rotation isn't some minor detail of how our planet works. It's one of the invisible pillars holding up everything we depend on: our weather, our magnetic shield, our very ability to exist on a livable surface. We never notice it because we've never lived without it. And maybe that's the real takeaway here. Some of the most catastrophic events imaginable aren't hidden in some distant, exotic threat. They're built into the quiet, everyday physics we never stop to think about. If this made you see our planet differently, subscribe, because next time, we're asking an even stranger question about the world you think you already understand.